This is multiple output flyback converter with PV source. In this, we are using a single control loop to control the multiple loads. How we are doing that means using the design of the coupled inductance. Because when we control the voltage of one load, the other loads will be controlled automatically by the turns ratio. Because if we provide 5 1 is to 5, 1 is to 10, 1 is to 15 to the ratio, coupled inductor ratio, and if we control any one of that load voltage, we can control the other two voltages automatically. In that we are using three R loads initially to control the voltage, and after that we have changed the loads to R load, RC load, RL load. That is RC load means battery, RL load means motor, DC motor, and the input source is PV. This is the simulation for the three R loads controlled by the single voltage loop, and here we are using PV and battery. Here the irradiance of the PV is varied according to the step function until 0.05 seconds. It is maximum irradiation, and after 0.05 second it is reduced to 300 watt per meter square. So the PV irradiation is changed. When it is reduced means the battery should provide the supply. In this, if you see, initially the battery was charging, so the SOC is increasing when PV is available. When PV irradiation reduces, PV is not available. So at the time the battery will be discharging. So the SOC is decreasing here. State of charge of the battery. This is of input side. And here this is the input voltage and current. Input voltage is initially around 14 volt, then it is reduced to 12 volt. Current is also initially it was around 2 amps, it is reduced to 1.5 amps when battery is providing the energy. And this is voltage control loop. Here I have provided 3.3 volt as the reference, and that is compared with load 1 voltage, and error is given to per unit conversion, and also amplifier, error amplifier. The amplified error is given to PI controller. The PI controller generates the duty ratio. This is the duty ratio. Initially, the duty ratio is very less when the PV is not available, and when the battery is discharging, the duty ratio increases to zero point 0.1 to zero point 0.2. And these are the output voltages for load 1, output voltage and output current for load 1. Here the voltage is around 3.3 volt, and it is maintained with both PV and battery supply. Current is around 1 amps. And for load 2 voltage, 5 volt is the output voltage and 1 amps is the current. And load 3 voltage will be 6.7 volt, and output current is around 1 amps. So all the voltages are controlled by a single control loop, and this is the efficiency. The efficiency is around 97 percentage. So the efficiency of the converter for R load is around 97 percentage. Now we have changed that load types. Here if you see means this is RC load, battery, battery voltage of 3.3 volt, 1.2 Ah, and second load is R load of 5 ohms. Third load is a motor load for 6 volt to 12 volt. Here in this if you see, the state of charge is increased now. For PV it is increased much better, but when battery is there, the rate of increase in the state of charge is reduced, and voltage is constant here 3.3 volt. And for R load, the voltage is maintained at 5 volt, and current is around 1 amps. And here for RL load, the motor speed is around 20 radian per second, so it is around 200 rpm. So in rpm if we measure it, it will be around 200 rpm, and the efficiency with the change in loads is around 80 percentage. For all the loads as RL load, the efficiency we achieved as 97 percentage. In this, when we provide RC load and RL load, the efficiency varies between 90% to 80%. It is oscillating between 90 to 80. So this is the working of the flyback converter with multiple loads with a single control loop and PV source. When PV is available, the PV will provide energy to the loads and also to the battery. When PV is not available, the input side battery will provide energy to the load. The voltage regulation takes place for both PV input and battery input. Similarly, when we change the loads, instead of R load, one R load, one RC load, and one RL load, the regulation is maintained here, but efficiency is slightly reduced. This is the working of this converter.